Hello everybody, let's take a moment to practice what we've just learned. In order to isolate our variable x, we need to move 7 to the other side of the equation. We do that by adding its inverse, negative 7, to both sides. Negative 7 and positive 7 give us 0. We bring down our x. Negative 7 and positive 14 gives us 7. If you add nothing to x, it's just x, which is 7. And there's our solution. X is 7. Okay, let's try another one. Again, in order to isolate our variable y, we need to move this negative 3 to the other side of the equation. We do that by adding its inverse, positive 3, to both sides. We bring down our y. Positive 3 and negative 3 gives us 0. 0 plus 3 is 3. If you add nothing to y, it's y, which is 3. And there's our solution. Y is 3. This next one looks different, but it's really just the same. In order to isolate our variable z, we need to move this positive 17 to the other side. We do that by adding its inverse, negative 17, to both sides. Negative 17 and 3 gives us negative 14, which is z, plus 0, which gives us negative 14 is z, which we can rewrite as z is negative 14. And there's our solution. Z is negative 14. Another one is pretty similar too. In order to isolate our variable w, we need to move this negative 11 to the other side of the equation. We do that by adding its inverse, positive 11, to both sides. Positive 11 and positive 4 gives us positive 15, which equals w. Positive 11 and negative 11 gives us 0, which leaves us 15 equals w, which we can rewrite as w is 15. If you followed through to the very end, you did a great job. Now let's move on to some different ones. These next few are pretty interesting. Let's start with our first one. Here our unknown is scattered on both sides of the equation. Think of these types of equations like a shelf where you have to put your unknowns on one side and your constants on the other. Let's start moving our unknowns by subtracting negative 2x from both sides. If you take away 2 of x from 3 of x, it just gives you x plus 1. If you take away 2 of x from 2x, it gives you 0 minus 4. Let's bring down our 1. If you take away 4 from 0, it's negative 4. Now let's move over our 1 by subtracting negative 1 on both sides. Negative 1 and positive 1 gives us 0. And there's our solution. X is negative 5. This next one is just like our last one, only with a different variable. Just like before, we need to bring all of our t's together by bringing them to one side of the equation. Finish up by moving our constant to the other side. Let's start by moving our 9t by subtracting 9t from both sides. If you take away 9t from 10t, that leaves you with 1t plus 4. Negative 9t and positive 9t is 0. Let's move over our 4 by subtracting 4 on both sides. Negative 4 and positive 4 gives us 0. And if you take away 4 from 0, it's negative 4. And there's our solution. T is negative 4. The next one is just like our last two, but this one has fractions in it. Just like before, we need to move our 3/5 w and our 8/5 w to one side of the equation, and lastly, bring over our constant to the other side. Let's start by moving our 3/5 w by subtracting 3/5 w on both sides. If you take away 3/5 w from 8/5 w, that leaves you with 5/5 w. Now we can bring down our negative 6. This gives us 0. 5/5 w can reduce to w. Minus 6 is 0. Let's move over our negative 6 by adding 6 to both sides. And there's our solution. W is 6. This next one is just like our last one. Again, we need to move all of our y to one side of the equations, and just look out for these fractions in between. Then we need to move our constant to the other side. Let's start by subtracting 2/7 y from both sides. If you take away 2/7 from 9/7, that leaves you with 7/7. Let's bring down our -3. This gives us 0. 7/7 y can reduce to 1y. Minus 3 is 0. We can bring over our -3 by adding 3 to both sides. And there's our solution. Y is 3. Let's move away from problems with fractions in them and move towards problems with grouping symbols. So let's take a look at these. Just like before, we need to bring all of our z variables together. But there's one problem. They're inside these grouping symbols. That makes them inaccessible. To get them out, we need to use the distributive property. This will open up the grouping symbols and take them out so that we can combine them into one term. So let's get started. Let's start by distributing -6 to both these terms. -6 and positive 2z gives us -12z. -6 and positive 1 gives us -6. Whenever there's not a coefficient outside of a grouping symbol, we assume that there is a 1 there. So 1 and positive 13z gives us positive 13z. Positive 1 and -7 gives us -7, which equals 0. Now we can combine our z terms and constants together. Positive 13z and -12z gives us z. -6 and -7 gives us -13, which equals 0. Now we can move over our -13 by adding positive 13 to both sides. Giving us z plus 0. If you add 13 to 0, it gives you 13. And there's our solution. Z is 13. This next one is just like our last one. We need to bring all of our unknowns together, but there's one problem. They're inside these grouping symbols. In order to get them out, we have to use the distributive property. Let's start with the first one. 2 of 5x is 10 of x. 2 of 6 is 12. Just like before, when there's no coefficient there, we assume there is a 1. In this case, the 1 is negative, so it's -3. The -1 and positive 9 gives us -9x, which equals 10. Now we can combine our unknown terms together. Positive 10x and -9x is x. Positive 12 and -3 gives us 9, which equals 10. Now we can move over our 9 by subtracting 9 from both sides. This leaves us with x plus 0. If you take away 9 from 10, that leaves you with 1. If you add nothing to x, it's just x, which is 1. Well, I hope this was good practice. Make sure to watch my next video where I show you how to solve equations whose unknown variables have coefficients that are not 1. See you next time.